Also, just as a reminder, for more Microsoft webcasts, you can visit microsoft.com/webcasts. And again, I'd like to welcome everyone to today's MSDN webcast, Windows Communication Foundation, top to bottom. Today's session is part 8 of 15, Instancing Modes. And now, without any further delay, I'm going to turn the floor over to today's presenter. We have Michelle LaRue Bustamante.
Thank you, Tracy. Welcome, everybody. We're here for yet another installment of our WCF series. My name is Michelle, and I'm an architect with iDesign. In case some of you have not been part of these webcasts before, I'll give you a quick briefing. And I'm also a Microsoft Regional Director. And I specialize in WCF, of course, just completing a book, Learning WCF, some months ago. And all of the code samples for that book will actually be posted and are already posted to www.indigogirl.com, which is shown at the bottom of this slide. So that's one of the ways you can reach me. And of course, dustblonde.net is my main blog where I post other types of samples and discussions from time to time. So just make a note of that so that you can get access to everything we're going to be doing today. Now, what we're going to focus on today in this webcast are instancing modes. And up until now, our focus on WCF has been some of the basics. So we've started with just how to build services and consume services. We've talked about contracts. We've talked about exception handling, which is going to come up again today. And we've also talked about bindings and hosting. And lastly, we did some messaging patterns on Friday of last week. So now what we're going to be starting to look at in the next couple of webcasts is more like the runtime allocation of resources. So instancing modes is one of those features. We're going to talk about how we handle and create state-unaware services, typical of web services, for example, how we deal with sessionful services and when they might be appropriate, and some of the implications of that. The appropriate use of singletons, which of course has many implications, and then just the overall impact of those instancing modes when we think about exception handling and so forth. So we'll talk about all of that today, and of course the follow-on to today's webcast will be throttling, which is something that goes kind of hand in hand with this topic, so we'll talk about that in the webcast this coming Wednesday. Now, the prerequisites, again, are that you at least understand how to build Microsoft.NET Framework applications and that you have got basic understanding of WCF. So if this starts to get a little advanced, you might want to go back and review some of those earlier webcasts. So the overall agenda from a high level, let's just start with a quick overview of instancing modes and configuration of that, and then we'll get right into the various instancing modes, which are per call, per session, and singleton. So just beginning with, what are the invocation scenarios you might think about when you think about a distributed system? So in the past, we've worked with things like enterprise services, .NET remoting, and ASMX for web services. And each of those really satisfies a different type of invocation scenario for an application. So you've got your classic client-server applications, which in the past might have been implemented with DCOM, for example. And of course, if any of you experienced that, you might have remembered that a lot of resource issues came about when we dealt with DCOM applications. In general, it was mostly related to the greedy client situation where we have many client applications that hang on to server resources for a length of time when they may not even be attending the machine any longer. And of course, with DCOM, those objects did not get released unless you explicitly did so at the client. And so classic client-server applications typically mean that there's state-aware objects that are live for the duration of the session with the client. And the clients actually have some control over the lifetime in that case when we talk about DCOM. Another scenario we might have is a distributed scalable application that needs to be servicing many, many more clients. And so the way we conserve resources is that we make sure we release those objects. And that might be related to a session timeout of sorts. That might be related to the fact that it's an ASMX web service and therefore doesn't have state awareness. So there's a number of ways to achieve that. And in COM, what we would do is have maybe JITA, or just-in-time activated COM objects, which means that over DCOM, even though you had a DCOM object, you actually released the object with every call, and then the object would be responsible for reestablishing its state if necessary for each call. And that gave us ability to scale a lot better in a distributed scenario. Then we've got the idea of, instead of clients hanging on to objects and instead of distributed scalability, what about the need for a single object that all clients communicate with? And that would be a singleton. Now, typically we don't want to see that in a server scenario, simply because imagine thousands and thousands of clients, even more, hanging on to or communicating with the same object. Obviously, we're going to have concurrency issues, which means multiple calls at the same time. We need to protect the resources they access. And that in itself can be a throughput killer. So what we want to do is think about the appropriate use of singletons, which may actually be more applicable in a client deployment. For example, two client applications that need to share communication with the same client-side cache or something like that. In that case, maybe you might have a singleton object that then communicates with the server to update cache to the database, that kind of thing. Or you might think about a singleton in a client-server scenario when you know there are a limited number of clients, so a very small application. So these are some scenarios that all had different applications in the past in terms of using DCOM, COM+, enterprise services, or remoting, and then possibly web services. So when we do classic state-unaware web service calls, that's a lot like the distributed scalable scenario, right? Where every call gets its own object and then releases the object when it's done. So WCF is capable of handling all of these scenarios. As you may recall from our discussion with hosting and bindings, we have the option of hosting in IIS for web services that are available outside the firewall. And we have the option of hosting behind the firewall using Windows services, for example. And those might also service classic client-server applications. And of course, when we have the Windows Activation Service in the future with Windows Server 2008, then that might be another option in terms of servicing all of the above. And with WCF, the way that we control the lifetime of the object related to these invocation scenarios, so whether it's client-server, classic, where the clients get access to the same object, or whether it's a singleton, or whether it's state-unaware, that's controlled by the instancing mode, or the instance context mode enumeration, which has three options. We've got per call, which is your state-unaware. We've got per session, which gives you a session with the client that's calling. And then we've got singleton, which is handled by the single option. And this is set by applying the service behavior attribute, which you've seen before in earlier webcasts. And you apply that to the service type, and that indicates its instancing mode. So that's how you control the lifetime of your service object. Now, that might look, as shown in this diagram, as follows. A client creates an instance of proxy, and for every call, a new service object is allocated. And that goes for another client and another proxy, and every call gets its own service object. And you might think, well, that seems like an awful lot of objects getting allocated, but remember the purpose of this would be that we're releasing resources quickly so that another resource can be given to another client, for example. And then that way we don't have a whole bunch of services running around in memory that aren't even being used because the client's walked away from the machine, for example, or the user. And so one of the things that this satisfies is a more scalable and an increased overall throughput to the server because of the fact that you're releasing those resources for each call. And of course, that would assume as well that the service itself does not have a large constructor. We're not initializing some sort of state awareness for the service object. We're simply executing an operation. So state is not maintained between these calls in theory. And then the services instance are freed immediately after each call. We consume less memory overall because we're only using the memory that's actually active with active clients at the moment. And we don't have concurrency issues because, of course, each service object is only communicated with by that thread. So there is no idea of multiple threads trying to communicate with the same service type. We'll talk about threading in the next webcast. Okay, so per call gives you overall increased throughput. This looks a lot like a web service deployment, for example, as you might get with ASMX in ASP.NET in the past. And so this would be your classic web service deployment in WCF. It also gives you your equivalent for just-in-time activation with COM objects, COM plus objects in enterprise services. So to configure per call, what we do is we apply the service behavior attribute to the class, and that would be the service type. So this is my service type, counter service per call, and here is my instance context mode set to per call. You have to explicitly set this, otherwise you actually get a session, because the default behavior is to give you a session. Now, to that effect, let me go ahead and show a quick demonstration of a per call service, and then we'll move into discussing sessions and singletons. So I'm going to share my desktop with you. And what you should see is I have a solution here, obviously, which has been pre-created. I've got a counter service. And in that counter service, what I have is a single operation called increment counter, which returns the new counter value. And that counter service contract has been implemented on the counter service type, which essentially in the increment counter, you'll notice that I actually keep a private counter member in the service type, which will be initialized to 0, of course, every time the service type is constructed, but it will be incremented every time increment counter is called. And presumably with per call, I will get a new counter value every time, simply because we're going to get a new object every time. So that will be what we see. Now the way to affect that is, of course, I need to add the service behavior. And that service behavior attribute is going to be initialized so that I set the instance context mode. And so the instance context mode that I'll select is per call. So there we go. I have the service behavior now applied to the service type. Now I'll go ahead and build that so we know that our service is going to work. And given that, I need to host the service. So in my host, I've already got it created here where we initialize the counter service and open the channel. And the configuration for the channel for listening has a single endpoint at the moment. So what I've got in here is a base address for TCP and HTTP. And I've got a basic HTTP endpoint exposed at the moment. And I've enabled metadata exchange simply because we're going to generate the proxy right now. So what I'm going to do is compile the host. And I'm going to go ahead and run the host without debugging. And then I'll go to my client and I'll generate the service reference. So this will be the first webcast where I'm illustrating this in Visual Studio 2008. So you're going to see a slightly different dialog here, because now there are actually some other options, advanced options that you can do for generating proxies. I'm not going to go through this right now, but I just wanted to illustrate that, of course, some of these tools are evolving with Visual Studio 2005 ORCID. So we'll go ahead and select this particular service endpoint, and the namespace defaults to service reference. I'm going to change that to localhost just because that's what we were seeing before. However, really what you would probably do is name that according to the service that you're adding, like counters or something like that. Now, at the end of the day, this generated, of course, a contract as we would expect in the references. So we've got an iCounter service contract. And we've got a proxy. All of this the same as what we have seen in past discussions. So at the client, I'll go ahead and consume that service. My app config is initialized with a basic HTTP binding endpoint, as you can see. And I'll go into the form here. And what we'll do in the form is just write a couple lines of code to create the proxy. And consume it. So proxy increment counter will return an int. And I'm going to go ahead and call it twice, because what we want to see is whether or not the same proxy gets the same service instance. And that will be that. Okay, so let's go ahead and compile the client and give it a run. Okay, so we've incremented the counter again. Notice there is no session ID because we don't have a session with the service, right? And we're using basic HTTP binding, which is a stateless communication protocol that does not support sessions anyway. Now, I made that point for a reason, because what I'm going to do is take the same code that we've just executed, and in the host, I'm going to change the endpoint. So instead of a basic HTTP binding endpoint, I'll comment that out. And I'm going to create a net TCP binding endpoint instead. Now, of course, TCP means that I'm going to have a socket, which is a transport session. And so we're just going to see the difference between using basic HTTP and using TCP. So I'm going to go ahead and run the host again without debugging. And then at the client, I'll just modify the config section. Remember, I'm using the defaults for the binding, so I actually don't need this binding section at all, and I don't need this binding configuration, therefore. So what I'm going to do is clean this up a bit and comment out the basic HTTP binding endpoint and create the equivalent of what we just created at the service, which is a net TCP binding, net.tcp, and port 9000, I believe. And now the proxy will be initialized with, of course, this new binding, which is going to be a TCP transport session to communicate with the service. And we'll make a call, and you'll notice I have a session ID. Now that's a transport session, which means it's a session at the channel layer. And notice that I still get an incrementation of a counter to 1 every time, which means I'm still getting a unique service object for every call, even though I have a transport session. In other words, there's more than one type of session, right? There's the idea of an application session where we explicitly use the same service object every time, and we're not doing that right now. We have a stateless environment. But we do have a session ID because we have a transport session, and it needs to make sure that requests coming in go to the correct socket, right? And to the correct channel layer in WCF. Okay, so with that, let me go ahead and head back to the slides, and we'll talk about per session or per call a little bit further. So what you just saw is that a new service object was allocated for every call. And that would be the typical thing I would want to see in a server deployment. In fact, I would argue that you should opt in to session or singleton with a decent argument as opposed to allowing that to be chosen, by default, because by default you're going to get a session. Okay, and I'll explain that in a few minutes. So you always want to set your services to per call unless you have a really good reason to have session or singleton. Why? Because it'll give you that scalability, that ability to release resources after every call. And how that might look is as follows. So a client creates an instance of its proxy, but for every call it gets a new service instance, and let's say we call operation A, and that calls down to some business component, which then calls the data access layer to do work. So what you might see is that you're creating an instance of the service, then the business components you need, then the data components you need for every single call, and then releasing them, of course, in client. Now again, assuming a stateless environment, typically your business objects, your data objects, your service objects do not have heavy constructors. You're not initializing a bunch of cached data. You're just making a call. And so this does actually scale. But if you find the need to cache some things, that doesn't mean you couldn't do so explicitly. This would just be the default behavior I'd expect to see. And again, this would be scalable. You don't have any concurrency issues because you're constructing the service, the business, the data object at each call. And so the only concurrent usage is at the database layer, which of course should be handled through transactions in terms of protection. Now, if you need to establish a cache for A or B reason, then of course that doesn't mean the service object couldn't call to a cache in order to return results, let's say, to the client. And of course, this could be part of an ORM. This could be something that you build yourself. But regardless, that cache now is introducing concurrency issues because now we've got the same object potentially, or the same resources potentially being accessed by different service objects and different threads. And so, of course, that introduces some complexity to your code, but the trade-off is that you might be gaining some performance in some way. So those are the two models I might see for per call. Typically, we'll see the former, which is you're just constructing objects as needed. And then as needed, you can introduce caching and such things to improve performance. But you should be able to get 350 to 500 requests per second, and we'll talk more about throttling next webcast, from a decent web server or application server in WCF, even with transactions and security enabled. So let's talk about sessions. Okay, so per call would be your typical scalable distributed application, but there are times where you may have some form of classic client server where you need to maintain a session for the client. And again, keep in mind scalability implications of this, because that does mean we're hanging on to the service object while clients may walk away from the machine. Now, before we can talk about application sessions, I want to make sure you're clear on the fact that there are actually 4 types of session in WCF. We've got transport sessions like TCP and named pipes, okay, and that's at the channel layer. And we've got reliable sessions and secure sessions, which are, again, at the channel layer, but they are application-based. And so those are part of, the web service standards, if you will, that have been provided for us to establish application sessions based on sending messages reliably and having retry and buffer for that. And then for secure sessions, reducing the overhead of authentication every call. So each of those things will be discussed in a later webcast, but I want you to be clear on the fact that those 3 are all at the channel layer, meaning that they're not related to the service instance and whether or not you allocate the same service object for every call. Only application sessions refer to that. So in this webcast, I'll be talking about application sessions specifically. And just the reason that I mention all of these sessions is because every single type of session may have some impact on the channel behavior when, for example, exceptions occur. Okay? And somebody has a question in the queue that says, what is NRM that I stated in my per call architecture description? And I'm sorry, but I don't know what the acronym NRM is standing for, so maybe you can clarify that question for me. Okay, so let's talk about per session mode then. I want to have an application session, which means something like this. The client creates a proxy, and for the lifetime of that client or proxy, it will communicate with the same service object. So we maintain the service object in memory at the server, which means that we can allocate objects that are maintained in memory as well, and count on them being there for the next call. So the idea is that a session is created between the client and that service object, and that session, unlike with DCOM situation in the past, will actually potentially expire. So there is a session timeout, which means we have to be aware of that and handle that. And the reason for the timeout, of course, is to reduce the potential of overloading the server with requests and or resource usage when the clients are no longer alive or active. So this is a bit less throughput since we might be using more memory, given the fact that the whole point of having the service object in memory is probably because we're allocating something in memory that we'd like to maintain between calls, right? And so there is that to consider. What is the amount of memory you're allocating and what is the overhead of that? The state, though, is maintained then only by the service instance. So this isn't like the ASP.NET state where it's stored elsewhere and potentially serialized. At this point, how WCF handles state with a session is that you allocate the state by maintaining things in memory as part of the service. So basically variables that you allocate. This does produce potential concurrency issues, meaning if this client is multi-threaded, multiple requests could come in concurrently to the same service object. So now you have to think about protecting the service from concurrent calls. Again, that part I'll be talking about in the next webcast. So in order to achieve per session, we have to have a binding that supports session. That means TCP or named pipe. That means for web services, we can only do WS HTTP binding because we need either secure sessions or reliable sessions in order to piggyback on top of HTTP and create the illusion of an actual session. And that all is exchanged through session identifiers. So you'll see that there's going to be a session identifier even for a web service HTTP binding. And of course, federation and dual HTTP binding both also support sessions. So WS HTTP binding, federation, and dual support sessions. Basic HTTP binding does not. I'm looking at a question here that says, if a per-call service is talking to a single instance of the database, couldn't the database become a bottleneck? Absolutely. So by definition, though, in a scalable deployment, first of all, your database is, although it does represent the most overhead in a request, it also is the thing that can usually handle the most throughput. So if you did benchmarks on, let's say 1,000K footprint, so nothing, too extreme, you're going to find that you can do, 100,000 requests potentially to the database, while the same on the application server is, something like 1,000 or 10,000. So if you look at the database as a bottleneck, absolutely it is, but at the same time, it's more of a bottleneck to do concurrency protection against, for example, an application cache, especially if it's poorly implemented. And database has been built from the ground up. Transactional programming has been around since, the 60s, 70s. And basically it's all built in, right, to SQL Server 2005 and other databases. So what you should expect is that the concurrency management is handled in an optimized way. And then we've got ADO.NET caching on top of that. So there's a number of things we can talk about there. Okay, so continuing with per session mode. In order to handle sessions, we do need to have a binding that supports sessions. And the other thing that we need to do is set the instance context mode to per session. But of course, that is the default behavior, which implies that I don't actually need to specify the service behavior at all. But I prefer seeing this explicitly marked on the class because otherwise developers may be unaware that they're getting a session, whether they like it or not. So you're actually going to be potentially getting a session when you're not expecting it unless you are explicit here. And that way developers are aware. You can also require sessions. So for example, if you set the service up as per session, what that means is if there is a binding that supports session, then it will work. You'll have a session, and the same service object will be allocated for each call. But if you're using basic HTTP binding, for example, then no, you will not get a session. And so it doesn't say anything about, do we need a session? And since an application that's built for sessions probably is expecting one, it's a good practice that you should require sessions on the contract. And so how we do that is we set the session mode on the contract, which can be set to allowed, not allowed, or required, and the default is allowed, which is why we sometimes get a session and sometimes don't. What that looks like is at the service contract we have session mode, and you can set it to session mode required, for example. And that will then, when implemented on a service type, any calls to that particular set of operations on that contract will then be enforced to have a session. So let's go ahead and look at another demonstration. And what I'll do is illustrate a couple things here. So we'll go to the counter service, And remember that we left this as per call. And now I'm going to change it to per session. So we have a per session service. Now, we really don't need to change anything else. The client doesn't need to be aware of the instancing mode of the service at this point. So we'll go ahead and start the host without debugging. And we will start the client and call the service. And you'll see that I'm incrementing the counter. And I do have a session ID, but remember that's the transport session ID of TCP. And it looks like the counter increments to 2 this time, which means the same proxy calling the operations one after another is actually getting the same service instance clearly. Now if I start another client, that would be a different session, wouldn't it? So we're going to start with counter at 1 and then 2 again. Now let me shut the client down for just a moment and make a change. So looking at the form code that we've got in here, my local host is actually we're reconstructing the proxy every time we make a call from the method, but instead I could allocate that to the duration of the application, or in this case the form, right? So what I'll do is start the client again, and of course every call now will continue to increment to 3 and 4 now, and so forth. And again, a new client will get its own session. So we'll make a call starting at 1, and then of course it gets its own counter, right? 5 and 6. So 2 separate clients, 2 separate sessions, and right now they're piggybacking on the transport session, which is TCP binding. Now let's go ahead and make a change to the binding. So I'm going to shut down the host for a moment. And what I'll do with the host is actually just uncomment the TCP binding, or the basic HTTP binding, so that we can support both. And at the client, let's go ahead and try the basic HTTP binding. So we'll run the host again. And then I'll run the client again. Client now does not have a session ID, nor does it have an application session. Notice the counter incrementing to 1 every time. Why is that? Because we're using basic HTTP binding. It does not support session, therefore we just don't get an application session. And you can imagine the impact this would have on a service that you've designed to support session like this one, where we're storing a counter. So what we should be doing is, of course, setting the session mode. And we'll set that to required. And then let's go ahead and try to start the host. We're going to get an exception. Says invalid operation. The contract requires session, but binding basic HTTP binding doesn't support session. And so what we need to do is comment out any bindings or any endpoints for this particular contract that do not support session, because we're requiring a session. And that also implies that now my client should not be using basic HTTP binding, but revert back to TCP. So I'll revert this back. And now my host will run, no problem. And of course the client will work once again and of course achieve a session because we're using TCP. There we go. Counter is 2. So therefore we have a session. So let's go ahead and take a look at a different example where I can illustrate a couple other things related to having a session and not having a session. Okay, so you've seen how to turn on session. You've seen that the binding has to support session if there's going to be one. You've seen that there's a session ID generated when there's a session, even if it's just a transport session, but also if there's an application session. And you've seen that we can require sessions at the service. Now, what is some of the other implications of using sessions or not are as follows. So I'm going to actually run an example that throws an exception and shows the difference between throwing exceptions versus faults and sessions. And I think you might remember that I talked about this a little bit in my faults and exception handling webcast. But let's just take a look at basic HTTP binding first. I'm going to create a new proxy. I'm going to make a call. The call increments a counter and has no session ID. Every call gets a new counter set to 1, right? I'm going to create a new proxy using, let's see, WS HTTP binding that has secure sessions on, which is the default behavior. And I'm going to use session. So we've got a session ID, and every call increments the counter. Again, now we're at 3, now we're at 4. So using WS HTTP binding, we get a session. Using basic HTTP binding, we don't. Now, what happens when I throw an exception on the basic HTTP binding? I'm going to go ahead and throw an exception. You see I got a false exception back. And I'm going to try and use the proxy again, and it still works. If I go back to the WS HTTP binding proxy and throw an exception, same thing happens. I get an exception, but now I can't use the proxy any longer. And we talked about this before. The reason is because we faulted the channel at the server. When the service throws an exception instead of a fault, it faults the channel because WCF thinks something very wrong has happened, and it doesn't think that it's safe to keep the channel alive. If you know the problem isn't fatal, you should throw a fault. So let's try that again by creating a new proxy, calling the counter a few times here, and then throwing a fault. I do get a fault that says not implemented, but I can continue to use the proxy and the counter is still intact. Therefore, my channel is still intact. So the summary of that is that for per call services, okay, if we don't have a session, we can throw an exception all we like. The proxy is still useful. If we use the same WS binding and we do a new proxy and we do per call, we still get only one instance every call, a separate instance of the service every call. But if we throw an exception, we still fault the channel. Why? Because there's still a session there. It's a secure session, application session. So that's what I was referring to earlier when I said there's different types of session in WCF. All of them have the same potential impact or the same result if you throw exceptions that are uncaught at the server. They fault the channel, they tear the channel down, the session's no longer valid, be it a transport, secure, reliable, or application session. So you must be aware of this at the client in terms of responding to those problems and recreating your proxy, because the proxy is no longer useful when there's any type of session, including application session. The other sum of this discussion is that, of course, it only applies if there is a session. So bindings that don't support session, like basic HTTP or WS HTTP with no session, don't apply. You can do per call all you like and never have to recreate your proxy, even in the instance that an exception is thrown. So let's see if there's any questions in queue here. A question here, in per call, we can mimic saving states bypassing state to a service and rehydrating. Absolutely. So this is just a good point, which is, of course, by definition, every call you make to a service that is per call, you're going to pass maybe a customer ID or something of that nature and go grab data from the database to do your work. So therefore, you are actually creating your own statefulness and restoring the state of that particular call based on the identifier. And that is typical behavior, absolutely. What instancing mode does ASP.NET Web Services have? Those would be per call. Why would we use named pipes instead of TCP? Okay, named pipes is for same machine calls, restricted to same machine, and only does Windows authentication. TCP can go cross-process and machines and has a much richer authentication model. How is the per-session object lifetime managed? Well, it's destroyed after every call. So essentially, when the operation has completed, WCF will tear down that object. And another question here, when we host per-call services in IIS, the client fires requests to 10 services at a time. Will the services run in the thread pool threads, or the services use a different thread pool? We're going to be talking about threads in the next webcast, but the summary of that is that it's both. ASP.NET is the first thread allocated, of course, through IIS, and then there is a passover to a WCF thread. And there are some details about that I need to explain to you, but I'll do that in the next webcast. So we'll talk all about that. And another question, is there any least managed concept like in remoting? No, not exactly. Okay, so let's continue. So we talked about sessions and per call. I've shown you how to turn on sessions, application sessions to be specific, and we've talked briefly again about exceptions and faults, which means you might want to review that webcast if you missed it. Now, session identifiers are generated for any session, whether it be a transport session like TCP or whether it be a reliable session or a secure session. By definition, we need a session ID if we're going to have an application session. And so basically, the highest level session ID will be used for the application session. So that would mean if you have secure sessions enabled, you'll be using that. If you have reliable sessions enabled, you'll be using that. At the end of the day, the point is that there is always a session ID when there's a session. And you can access that session ID by accessing the proxy's inner channel session ID property. The session identifier is passed with every message, and it's important that that's used to make sure that the request is funneled back at the server to the same service object if there's an application session. So the session lifetime is about 10 minutes if you use the defaults. But there is a way to control timeout, so there's a received timeout property on all the bindings. This is an example initializing the net TCP binding for a received timeout of the default value. This is the format of it. You can change that to 30 minutes if you like. You're probably not going to go much beyond that, given the fact that what you want is that if the clients are not using they're not active for 20, 30 minutes, then clearly they may have walked away from the machine for who knows how long. We don't want to keep that object alive, so we tear it down. And of course, you know, if a client is to do that, they need to be aware at the client side to reestablish a new session when they come back if it has timed out. That means recreating the proxy. You can also explicitly control the lifetime of a session by the operation. So in fact, you can create the concept of a start session, stop session operation using the is initiating and is terminating properties of the operation contract attribute. So here's an example where I've got a session service where we require session. where we say that the start session operation is initiating set to true and is terminating set to false, meaning when this operation is called, it will create a session if one does not exist yet. It will not terminate the session when the call is complete. This is the default behavior. Now, if we want to make sure you call start session before you call any other operations, then what you want to do is have increment counter, get session ID, for example, set is initiating to false, which means you're not allowed to call that unless you've already called an operation that creates a session. So if a session does not exist already, this will not be a legal call. We also don't want to terminate the session after these calls, but we do want to terminate after stop session. So what we do is we set is terminating to true. So this would be an example of an interface that supports sessions and that requires sessions and that forces the user to make calls in a particular order. And that can be useful in some cases. So let's go ahead and take a look at an example. So here I have a service called session service. It's the one we just looked at, so I won't spend too much time here. Session mode is required. Start session initiates the session. Stop session terminates the session. And everything in the middle requires that we already have a session. The instancing mode is per session, of course. We are hosting this with an endpoint of NetTCP binding. So we have a transport session to piggyback on top of. Okay, so let's take a look at what happens. We'll just give it a run. Oops, I'm probably already using that port, so let's go ahead and shut down the last example. And start it again. Okay, so what we're going to do is create a new proxy. And I'm going to try and call increment counter. Now notice what happens. Cannot be the first operation called because is initiating is false. How does the client know this? Because when we generate the client proxy, in fact, all those attributes for initiating and terminating are also brought over to the service reference. So basically to the contract at the client. So you'll see is initiating. Well, the defaults apply in this case, which means is initiating is true, but in this case, is initiating is set to false for increment counter, which is the operation I just tried to call. So the client proxy will help prevent calls getting all the way to the service and failing. Instead, they'll fail right there at the client when you make the call. So the client channel will enforce this behavior, in other words. Let's try this again. And this time, I'll do the right thing. Create a proxy, start the session. So now we've got a 30-second window because I've set the timeout for 30 seconds. We'll call increment counter a few times and then call get counter. It's now at 4. We'll call get session. That gives me my session ID. So there's some code in here that shows you how to get the session ID. And then we've got stop session. And of course, after stopping the session, I can't just start session again because, in fact, stop session does what? Well, it basically tells the server to terminate the session and the channel that's been allocated for that particular client. So you can't use the same proxy anymore. We have to create a new proxy. So that was illegal, what I just attempted to do, because I killed the session by calling stop session. Let's see that in a different way. I'll create a new session, which is a new proxy in this case. I'll start the session. I'll increment the counter a few times, get the counter, it's 8, stop the session, create a new proxy, start session, and away we go again. Increment counter a few times, and so on. So the point here is that the session will remain active for whatever period of time the client continues to make calls to the server. If it's inactive for whatever the timeout, it will actually kill the session at the server, and the client will find out when it makes the next call that that's going to fail, and we'll see that in 30 seconds when this timeout happens. If you explicitly stop the session, you have to create a new proxy. So these are things the client side should be aware of too when it's consuming WCF services. Now, how is this different from what we're used to in the past? Well, in the past, first of all, we didn't really have anything like this that had the concept of N-tier client server with access to the same remote object, whereby there's actually a timeout. It's more like the client could be greedy and hang on to the reference for an indefinite period. Either that or you had just-in-time activation. So what's nice about this is that we have sort of the best of all worlds because we can still force a timeout to preserve some of those server resources. Now at this point, increment counter should fail because I think 30 seconds have passed. And it says that the socket has been aborted because it's a TCP session that has now expired. And therefore, we can no longer use the proxy. So that would be, an exception we'd have to catch in order to recover and create a new proxy because of the session timeout. So let's continue. I'll see if there's any questions again. Does is terminating, one of the questions, does is terminating override receive timeout? Well, yes, in the sense that is terminating set to true means that if a user calls that operation, it will kill the session. Receive timeout kills the session if the user's inactive. So they're not the same at all, but the same result happens, is that we kill the session. Another question, just taking a look to see which ones are relevant to this current discussion. Some of those might wait till later. In terms of session timeout, if you have to enter your password to start watching the webcast and have to enter it again to fill in the survey, is there a way to configure the timeout so I only have to enter the password one time? I'm not really sure I understand this question. I think what you're asking is whether or not if the session times out in a WCF instance, do you have to authenticate again? And the answer is by default, yes, of course, you would have to authenticate again because you don't have the session any longer. Now, if you want the client to cache the credentials, meaning the user's already provided a username and password when they loaded the application, you can hang on to those and provide them silently when you recreate the proxy, and that would be fine. It might get a little more complicated if you're using a secure session, though, because you're going to have a token that also has an expiry. So there's all kinds of details that might go into that. Okay, so let's continue. So the per session architecture then. You've got a client creating a proxy, hanging on to the same service instance. However, you still may have unique instances of the business services constructed and the data services constructed for each call down to the data store. So just because we have a session at the service tier doesn't mean we're hanging on to these business objects indefinitely. You still may have state-unaware business objects and data objects, and that will give you some level of scalability downstream from there. And that also means we're not hogging our memory with all of these business and data objects running around indefinitely while the client is inactive. You're still going to have concurrency issues for multi-threaded clients, like I said before, because these multiple threads could come into the same service object. So you have to keep that in mind. Now, in terms of state, your state for the per session architecture may just be state in memory that is other objects besides the business objects and data objects. So, you could optionally hold on to business objects and data objects, like I said, for the duration of the service type being held on to by the client. But more than likely, you're going to have other state that is maintained by the service that is maybe used to call downstream. So let's talk about singletons then. So a singleton service means that we have a single object for all calls. This clearly has the least throughput and potential for concurrency issues because every single proxy, every single call, all goes to the same service type. So anything the service does in terms of communicating with in-memory objects, talking to a cache, talking to the database, which of course we would expect anyways, is going to mean concurrent calls going against the same resources. Which means if we only let one in at a time, we don't get as much throughput as if we can have multiple concurrent calls. Configuring singleton service implies that we set the instance context mode to single at the service. And let's take a look at how that works. So going back to the demo that we started out with, if we take a look at this and make it a single service, so my instance context mode now set to single, and right now, if you recall, I'm hosting over TCP. And if you recall, I have required session. So what's going to happen here is we'll start without debugging. I'll start a client, and I'm going to start two clients just so that we have a couple of different instances of the client running. And we'll call the service. We've got a counter incrementing to 1 and a session ID. Why do we have a session ID? Well, because we have a transport session, and also because we required session at the server. Notice ID equals 1 at the end of this session identifier. Incrementing the counter to 2 at the first call. Now let's go to the second client, and that increments the counter to 3, but has ID equals 2 as a session identifier. So in other words, the singleton can still support session identifiers that uniquely identify each caller in case you needed to, in the singleton, allocate different dictionary values or something of that nature to each calling client. Now, of course, more than likely, you don't want session with your singleton. So if we actually wanted to remove that, what we'd have to do is say not allowed, because if we say allowed, we will get a session if the transport has a session. You get the idea. And of course, by saying not allowed, we're not going to be allowed to use TCP binding. If I start the host right now, it'll fail. The opposite exception from what we had before, which is we don't allow session, but TCP requires a session because it's a socket. So what we're going to do is we're going to use basic HTTP binding, and the host will run. And then at the client, of course, we will revert back to our basic HTTP binding as well, comment out the TCP binding, and we'll try that again. And now the client doesn't have a session ID, but we still do increment the counter separately from multiple clients. I'll load up another client, and it's incrementing the counter 3 and 4, 5 and 6. Go back to the original client, 7 and 8, right? So singleton still serving all of our clients as we would expect. So singleton is a pretty easy concept to understand. The architecture of it is that, typically, if it's state unaware, then what that means is that we're not maintaining any particular state for each calling client within the service object. But it's possible that a singleton could keep alive business and data objects to service every call, which again means, holding in memory whatever those business and data objects maintain and needing to protect each of those objects from concurrent access. So anything shared needs to be protected from concurrent access. Another model might be that we have some state for each client, perhaps, and another option might be that we construct business and data objects in a per-call fashion through the singleton, and therefore the only purpose of the singleton was the actual state that we maintained for each caller, and maybe some other, runtime cache and other features that are separate from the actual downstream business functionality. So in summary then, what you want to think about in terms of instancing is the following. You're always going to prefer per call. Why? Because it's more scalable and yields better throughput. Yes, the database is a bottleneck in the sense that it will need to protect itself from concurrent access, but it's designed to do that and can handle that at a much better scale than if you did benchmarks in terms of the number of inserts per second and compare that to the number of application calls per second. The database will yield a much better throughput in that respect. It's still overhead to connect and so forth, but there is other things like ADO.NET connection pooling and so forth. So what you'll find is it's the overall best scalability and throughput to use per call. Per session, use only when needed because it's got a lot of implications. Overhead of the sessions at the server, potential for timeout, and so forth. It's also got implications when we use transactions and other features. You want to avoid singletons altogether if you can, but it could be useful in client scenarios, and that's really the only place I ever recommend people consider it, unless you know that you have a simple application that has a limited number of users connecting to the service, in which case perhaps a singleton could work for you. So with that, just to remind you, all the codes that I demonstrated today and other code samples can be downloaded at thatindigogirl.com. Today's demonstration was in Visual Studio 2005, but my samples that are posted here are currently 2008, I meant to say. But the samples posted are right now 2005 using the WCF CTPs, and either or will run with the 2008 environment. They just need to be upgraded, the projects. Very simple. In terms of other resources, if you go to iDesign, we have a lot of WCF resources there. If you need a book to back up some of this stuff, of course I finished my Learning WCF book several months ago, and it's got labs hands-on in there as well, but like I said, all the code's already available. I've already posted the VB labs as well, and the VB code forthcoming. With that, I guess I'll go back to the questions and let Tracy take over here.
Excellent. Thanks, Michelle. And I do want to remind everybody that for more information, they can print a PDF of today's session. And to do that, you just want to go to the File menu in your upper navigation bar. Also, I'm going to be posting a survey here in just a minute. If you would all please take a moment to fill that out before you log off. We really do appreciate your feedback. As a reminder, for upcoming and previously recorded webcasts, you can visit Microsoft.com/webcast. You can go here to access this webcast, which should be available for download in about 24 hours. Now, if you have any webcast content ideas, something out there that you'd like to see and you haven't yet, we'd love to hear from you. Please take note of this link here. And for anybody who's interested in receiving a free 14-day trial of Microsoft Office Live Meeting, you'll want to visit Microsoft.com/presentlive. And here is the survey for the session today. Please follow the links provided to complete today's webcast evaluation. And now, Michelle, do you have any questions waiting there for you?
There are a couple of questions I'll go ahead and answer. One of the questions is, what happens to remoting after WCF? So remoting really is not something I would even explore now that we have WCF. The only thing remoting can do that WCF can't do, but I'd still not use it, is a cross-domain in-process calls without serialization, because you can do Marshall by reference. So WCF, of course, is always serialized, so there's no Marshall by reference. Therefore, you're going to pay a serialization overhead to do cross-domain in-process calls. Because cross-process and so forth, serialization overhead compared to the fact that you're crossing the process and so forth is just not something I would even think about, and therefore I wouldn't think about remoting. A client, I think the person is asking whether or not I can authenticate the client on each call and instead authenticate them once per session. And the answer is yes. Of course, the session is the proxy. So remember, the proxy, when you first make a call to the server, is going to do the authentication, and then from there establish some sort of session whereby we don't need to re-authenticate every time. Now, the proxy will hide a lot of that from you, so I think maybe another part of this question is, look, what does the user see versus what's really going on underneath? What the user sees is they authenticated once into the application. The proxy was given the credentials, if you will, is the username, password, or the dialog that popped up, and then the proxy maintains those for the lifetime of the proxy. And in fact, even if you create a new proxy, you could pass those credentials again. Now, in terms of the lifetime of a single proxy, subsequent calls to the service may indeed authenticate every time unless there is something called a secure session with the server. So I'll be talking about security in a future webcast to talk about those details. Do I recommend using Visual Studio 2005 or 2008 Beta 2 doing examples from my book? I guess what I would say is this. Right now, I mean really, all of those samples from my book, I've started upgrading them to 2008, and once I'm done, of course, I will post those as well, but I think I'll work on the VB samples first. I just did a few for this webcast. And essentially, I just had to go through the wizard to upgrade the projects. One point to note is that I did the upgrade by opening the solution using File Open as opposed to double-clicking the solution file because that didn't seem to be happy. That will probably get better, of course, with later updates to the beta. So I guess I would say this. Use Visual Studio 2005 if that's what you have already set up, and it's not going to hurt you. But if you're already using the beta, then just update my sample and go for it, because I think that that way you get experience with the latest and greatest, right? I would recommend that. And if you have any questions, feel free to email them to me. I may already have some samples translated that I can send you too. Where can you find more on the different kinds of sessions, application, secure session, etc.? Well, this webcast focused on application sessions. Certainly I'm going to be talking about reliable sessions and secure sessions in an upcoming set of webcasts, so you can go there. I do talk about the differences between all of these sessions, of course, in my book. In Chapter 6, I talk about reliable sessions. I talk about secure sessions in my security chapter. And I talk about the differences between them in Chapter 5 on instancing. And somebody was trying to clarify that maybe earlier the person's question was asking about what is ORM, which is Object Relational Mapper. Question about the difference between myself and my colleague Yuval's book. Essentially, a couple things. I guess one is if you're getting started from the beginning with WCF, you're probably going to have an easier time starting with mine and then going to his, because I have hands-on labs and it is trying to target sort of beginner to intermediate. Yuval's book assumes you are already a seasoned enterprise developer and that you understand those concepts, and therefore you're just applying your historical knowledge to things like security, transactions, MSMQ, and so forth. And I guess lastly I would say there are things each of us focus on in greater depth that complement each other. Where I focus on contracts and web service standards and related to those issues, and more on hosting and how to build a Windows service, for example, and more on security related to federated security and card space, Yuval focuses much more on MSMQ and transactions, for example, and has put some of our other iDesign utilities that he's created into his book. So that would be another way to look at it. I would go from mine to his, and I think that both will give you great value. And I guess that's the last of the questions, so thanks everybody once again for attending the webcast. I appreciate your attendance, and I look forward to seeing you next time.
Great, and with that I do want to extend a very special thank you to Michelle for your presentation today and answering all the great questions we had come through the queue. Well, ladies and gentlemen, this is going to conclude today's session. Thanks for joining us. You may now disconnect from the audio portion of today's presentation.